What's the smallest Linux distro? Well, we know that Ubuntu, which is 1,800 packages, is bigger than Arch, which only has 456. Alpine, however, has only 28. Can we have just one package, just Linux? As it turns out, you don't even need a bootloader. Modern computers boot via UEFI. The entry point is no longer the first sector of the disk, but an actual file in PE format, like a Windows executable. Linux has an option to disguise in this format, so it can boot directly without a bootloader. The question now is, how small can Linux get? This is the first episode in my Linux from Scratch series. Across 5 episodes, we'll evolve the speedrun into an actual system. tinyconfig is a common starting point for embedded systems. It disables everything, so we have full control about all the options, and also introduces some minor and interesting things that make the kernel smaller in size. So what do we enable? This screenshot comes directly from my notes when I was preparing the speedrun. Have a look. We'll start with some general options. Linux by default targets 32-bit, so we need to enable 64-bit. ACPI allows us to do a really cool thing called shutdown. People take it for granted, but in the mid-90s, the normal was getting something like this. EFI is a synonym for UEFI, and EFI stub lets us keep the bootloader. Since we don't have a bootloader, nobody is helping the kernel know where to boot from or how, so cmd line lets us specify that. The program loader is inside the kernel. It's called whenever an executable file is run. With these two options, we allow both ELF, that is, regular Linux executables, and also scripts with shebang, TTY, so we can interact with the system locally. These are basic Linux file systems that programs will surely require: dev, proc, and sys. Finally, futex for logs so threads are possible, and printk so the kernel can print to the screen and we see if there's any issue. Instead of building support for a screen, which is a heavy concept, we just use serial, which is much simpler and compiles much faster. These are drivers for the virt.io interface, which is the native of KVM. Our root file system is ext4, so we need the kernel to understand it. If we want to change the kernel in the future, and believe me we will, we'll need to mount the EFR partition. So we enable FAT and some essential extensions. Finally, network, including Unix, which enables local sockets, and inet, which gives us IP and TCP. Packet is for raw packets, we need it for DHCP. So that's all, that's the usable bare minimum. However, I later came across this, KVM guest, another profile like tinyconfig, which actually includes a lot of our options. So even though it enables more things, it's less time typing, which generally is the bottleneck of a speedrun. This trick removes all these options. And that there is the final list you can see in the speedrun. That's it for the kernel. However, if we boot, we'll get something like this, no working init found. This is because the kernel is not interactive, so what do? We need tools. These are some of the common tools in a regular distro, but there's a very cool project called BusyBox, which ships simpler versions of these tools in just one package. With BusyBox we can do many things. We can write a book, or even access the internet, painfully.
You can do a lot of different things on the internet.
However, we want an actual text editor or a web browser, but we can't install anything unless we steal static binaries from another distro. We need a compiler, a C compiler to be exact. One of the smallest C compilers out there is TCC, the Tiny C compiler, and it fits great for the speedrun. Let's try to write a program for our distro. I already messed up, let's see why. We're missing a standard library, which is needed by every program in existence except the kernel. There are two main alternatives here, the huge GNU libc and the quite small musl. Seems like an obvious choice. When a program runs, it may need dynamic libraries, pre-installed in the system. The libc is the main one. Nevertheless, dynamic libraries need a complex and stable environment, so here instead we'll compile everything statically. We include the libc inside of the binary. So that's it, those are the 4 pieces: Linux, BusyBox, musl, and TCC. Let's now very briefly walk through the speedrun. We are using LiveSlack, a Slackware live CD that includes a huge set of tools, including those needed to compile Linux, which are not few. 2 partitions, EFI and root. We have to mark the EFI one in its category, and the root gets the default. We format and mount, and then we grab the kernel and unpack it. Then we apply tinyconfig and kvm guest, and enable the options. Now we set the cmd line. This is very important because it's when we tell Linux how to boot. We point to the root partition, make the system writable, and tell Linux to use the serial as the main interface. We set the init to the shell, which is the only thing there is, and we're done. Now we grab muscle from their terrible server and configure where to put it. We also disable the dynamic library because we're not going to use it. We now compile it and also install it locally. This is a very bad idea, but we're in a live environment where it doesn't matter, and it simplifies future commands, so we don't mix libcs. Then we install into the mounted system. Now we grab busybox from their also terrible server, enable the default configuration, and modify the configuration file to enable static linking. We also do some shenanigans to make it use muscle. We now grab TCC from their horrible server, we configure it to use muscle, and compile and install. That's it, it's actually a very simple process, the hard part is the decisions. Hope you enjoyed, see you next week, when we'll start improving the install from the inside.